My name is Garth Williams, and I'm not Austrian, but I've been living here in Vienna for about 7 years. I'm a freelancer, and I've worked in various places, including the UN and Diamond Dogs. So I've been developing for quite a few years, and I'm going to go over a little bit of history, and this is a journey, so you have to excuse this, but we're going to start kind of way back at the beginning, or at least my beginning, of software development for the web. So I wrote my first web application in around '96. I'd been developing before, but this was my first kind of real browser-based application. Perl, static, HTML. I think there was even an Access database in there somewhere. There was no CSS. I'm not even sure it was around at the time. No JavaScript. Very few frameworks, maybe a few Perl libraries, but basically everything was done by hand. So you would have a script on the server that would sprint out HTML, sent over HTTP, the browser would render, either follow links or post back data, and the Perl scripts would process that data and repeat. It was simple, fairly elegant, but it was also a very good foundation. It helps you understand, when you work at this level, really what's going on with HTTP and with HTML, even though at the time there wasn't very much of it, but it's a good foundation. There was no browser scripting APIs and nothing to kind of distract you from the basics. Around the end of the 90s, I think it was 1999, they finally came out with ES3, which is kind of the foundation for JavaScript as we know it today. And this was implemented in Internet Explorer, although it was JScript. And at that point, we basically had a client scripting framework, but it came with its issues. And if you were programming back then, this is the kind of thing you would see a lot. There were standards, but there was always more than one, and you had to know them all, or at least you had to know at least 2 or 3 of each. So, JQuery. JQuery was basically, I think, the first time that we could, as a developer, relax, not worry about the differences of the browser, and just concentrate on the application logic. I mean, there were alternatives to jQuery. I think Rails used Prototype, and there were probably others. But jQuery was simple, and I think it's the kind of the foundation for a lot of the APIs which finally made it into the browser that we see today. Of course, you could do a lot with jQuery, and you still can. But if you want to build large applications with something like jQuery, which is basically just a browser API abstraction, it's not really giving you the tools that you need to create large, scalable applications. And when the single-page application concept came along and we tried to do it in jQuery, we often ended up in this complicated situation of managing all the different data flows with the application. So there were a few frameworks that came along to help us with these problems. And this is my list that I came across in no particular order. And yeah, there may have been others that I didn't come across that you might know about. But Backbone was very popular, and I think still is. But it's not really a complete implementation.
I think it's better that way.
Better that way. Okay. Extjs, I don't know if anyone of you came across that. I think it's called Sencha now or something. But basically, in my opinion, this was trying to emulate the desktop in the browser and wasn't really innovating that much when the browser had so much to offer. I think the first time I did something similar to this was back in my university days. I think I tried to make a Windows Start menu in the browser, which at the time seemed like an amazing thing, but had no real practical use. Cappuccino. Cappuccino was very promising, and I think it's also still around. I don't think it hit 1.0 yet, even though it's still been going for many, many years. The only thing with Cappuccino is that you have to know this thing called Objective-J. It's kind of like Objective-C version of JavaScript. So yeah, it's interesting, but didn't really hit it, I think, with most people. So then came Sprout Core, and I think this was popularized by Apple, who based some of their online iLife applications on this framework. And this seemed to be like it was going in the right direction. Okay, Sprout Core, it was based on some of the Apple concepts with Cocoa framework and messaging and so on. But yeah, it seemed like the right direction. It was a little bit clunky. You needed Ruby on the back end to compile your application. Yeah, and it still kind of felt a bit like a desktop app. The original UI that they came up with it and you kind of had to use was kind of based on desktop concepts still. Sprout Core 2 came along shortly afterwards, and this was basically, let's get rid of all of this server-side preparation needed and just create a script that you can import into the browser and just use it as a framework without Ruby. And finally, we had, I think anyway, arrived at something that worked. A framework that supported all of the features that you would need in order to make very, very complicated applications. I worked on one application with some of the people I see here, which was quite large. I think we had a team of 10 or 15 people working on it for a couple of years. So quite a sizable application. And Ember supported the scale. It supported the multiple people working together on one large application that many other frameworks we would have struggled to do the same with. Ember.js had routing built in. Routing was based on a state machine, which at the time was a brand new concept. The fact that as you move from A to B, as you transition, you get to fire events. Yeah, it was very difficult to get out of sync. Your app was always kind of, yeah, it was a full MVC. We had templates, we had binding, which meant that as your object's properties changed, all of those changes were reflected everywhere in your application. Great. Also had some negative sides. It had its custom object system. In order to support binding, you had to use getters and setters. You had to do a bunch of things in order to keep everything in sync, and it had its own object system to support that. It would have been really nice just to use plain old JavaScript, but unfortunately you couldn't. And that was kind of, I think, one of the temptations of Angular, although that was a very brief temptation for me. Templates. Templates are good and bad. On the one hand, they kind of enforce you to put logic maybe where it's supposed to go, but on the other hand, why can't I just use JavaScript? You know, you've got always this struggle to replicate the logic that you need when the language already has what it needs for it. And data binding. Data binding initially seemed like a great idea, but as your application grows or as the complexity of bindings grow, you soon lose track of all of these different messages going in different directions at the same time, and where is the state, and it gets complicated. Then came along React. Now, React was an interesting idea, but React, as it said on their homepage, I believe, the V in MVC, was based on some interesting and fairly new concepts, at least for me. Virtual DOM, high performance, don't need to worry about interacting with the slow browser DOM implementations directly. You don't need to worry about updates, just render the whole page every time, even for a little minor update, which is kind of a little white lie because most frameworks will actually do those little updates for you rather than re-rendering the whole page. But anyway, that was kind of the story that we were told. And React was around for a little while, not too long, but it was a V looking for an M and a V, M and a C. There was nothing to go with it, and people tried cobbling it together with other frameworks like Backbone, but they didn't really kind of fit, and people ended up kind of folding back into the old way of doing things rather than embracing the future that it could bring. So then what happened is we ended up with Flux, and Flux was basically Facebook's answer to the missing model and controller. But Flux at the time was vaporware when they announced it. It didn't exist. This was just basically a concept. And eventually there were some implementations that came along, and they were all a little bit different, and kind of some worked better than others. And of course, some are still around. And Flux was based on this. So you have an action. Well, the basic thing is you've got unidirectional data flow. This was the big thing. So we don't have bindings that send data in two directions. We only send data in one direction. We have an action with a payload, which is given to a dispatcher, which then decides which store to call. There can be many stores. This was the original implementation of Flux, and yeah, how did that get there? Then we've got views, which are bound to the state of the stores, and in theory will automatically update whenever the state changes. It's great. But there was a lot of confusion. Where does my data go? Well, the data goes in the store. Where does my logic go? Does it go in the action? Does it go in the dispatcher? Probably not. Does it go in the store? Maybe. Maybe it goes in the view. I mean, I don't know if anyone's using controller components, but basically that's kind of putting logic into your view. Where does routing go? And I think that the React router is still kind of embedding logic in the view if you're using that kind of thing. So this was good, and it was a step, I think, in the right direction, but it still wasn't what I was looking for. Maybe some people stopped here, or maybe they haven't yet found the next step, but for me, this wasn't quite it. Cerebral. So I found Cerebral through blog posts and meeting people back in early 2015, so not that long ago, just over a year and a half ago. And I think the first blog post from the author, Christian Alfoni, was in around May 2015 with an introduction and preview of Cerebral, an actual implementation. I think this was a couple of months before Redux was announced back in July of last year. So very, very similar timing. People are coming up looking for solutions for similar problems, and they have slightly different answers, but they're solving a similar space of problem. So like Redux, like Flux, we have one-way data flow. We have a single state tree, preferably immutable, although it doesn't have to be. And this solution, it resonated with me, and I'll explain why. It helped me solve large, complex problems by breaking them down into smaller parts. It also seemed less repetitive than Flux. In Flux, you end up with, I think, a lot of boilerplate when it comes to defining dispatchers and action namings and big switch statements, and I found some of this stuff a little bit clunky. So at its core, Cerebral has a single state tree. Immutable, by default, there's also an option if you need performance later on. You can basically swap out for an immutable for a mutable tree without any API changes. The main interesting thing is you have a concept of signals. So a signal is basically a chain of actions that get triggered. And each action is a small composable piece of logic. So you can break down a problem into many small parts, and we'll look at one in a moment. And for a view layer, it integrates with React, Inferno, SnapDOM. I think there was at one point an implementation that worked with Angular, but it was not really well maintained because we didn't have many people interested in that. But this is what it looks like. So we have a state. The state is used to render a view. The view will fire a signal, and the signal in turn will call a chain of actions, and each action can synchronously or asynchronously execute, and they have the option to mutate state, get state, call server operations as you wish. So this is an example chain. This chain is showing a login process. So we basically have a number of actions defined here. And the point of a chain here is that we end up with a very high level and readable process, so we can see what happens. So at the beginning, we're going to set a loading state. Might start off a spinner or whatever within our application. We then have an action which will validate the data of the form. If the form is valid, we hit the valid state. If it's invalid, we will jump down to the invalid and show an error message. If it's valid, then we are going to post some data to the server. The server will respond with success or error, and we can continue. But this makes the system, it makes the activity that you're performing very high level and easy to read, and easy to understand. Of course, these actions can be anything you want. Cerebral comes with a number of inbuilt actions called operators. So there's two here demonstrated, copy and set. So these are basically just shortcuts which help you move data from the data that comes in as the payload into the signal, into the state tree, or from the server, or wherever you like. But this makes it very easy to reason about your application. This is what an action might look like. So each action takes an input, a reference to the state, and an output. There are more options if you want to delve into it, but these are the basic three that you would use in most actions. So in this case, we're going to get the form. This is an example of the validate login form. We're going to get the form. We're going to check that they've actually entered something in the username. If they haven't, we're going to show an error. If they have, then we're going to continue. There's a commented out piece here. If I'd mark this action as asynchronous, then the system would support that. It would update the view automatically whilst it was waiting for the asynchronous action to complete, and then continue when the output functions are called. Defining a signal is very, very simple. On the controller, and there's only one controller in Cerebral, you can add one or more signals, and each signal is normally named according to the event that happened. So it's login submitted. This is what happened. And then we assign that to a chain. So this is what will happen as a result of the action. Okay, the view. So the view is basically binding signals, which are basically functions, to events. And Cerebral will take care of making sure it gets called and all of the actions will get executed for you. Okay, so Cerebral apps have a pretty well-defined structure. They also support modules. You can import modules from NPM, and there are a bunch of pre-made modules supported by the core team, and also some third-party modules which you can bring in, or you can even publish your own. Also, you can use these modules to test parts of your application in isolation. Makes Cerebral very testable. The view layers are extremely thin. Normally, you would have no state in your view. You would have no logic in your view. Even if you wanted to sort a list of items for rendering, you would do this outside of the view state. And the sorting logic, the output from the sorting logic would be cached so that you don't rerun the sort every time the view updates. And it has a bunch of tooling included. So it comes with a very good debugger. I would show you if I had more time. But the debugger basically lets you see every action that gets executed, the data that goes in, the data that comes out of it. It will show you the current state of the tree, and you can look at the data as it was at the time that the action ran, not necessarily as it is right now. It makes it very easy to find problems in your application. Well, I think that's quite a common feature of a lot of frameworks these days. It also has plugins for Atom. So if you're building up a signal, very often you'll sit down with a team of guys and you'll say, okay, we're making some complicated signal. It's going to have these actions. This is what it's going to do, but we have no implementation for them. You can just, through a few keystrokes, automatically generate all of the action files as stubs, and then you just give them to your team to go fill in. So it makes it very easy to create apps.
In which environment do you run this? In the functional JS or browser?
I mean, this is, the tools are running in Node, Chrome debugger, but it'll run in any browser. This is a browser-based thing, although You can also run Cerebral server-side if you want to do server-side rendering, which is also fairly common. Also has a CLI for generating kind of initial bootstrapping your app. Okay, now I'm going to skip over a couple of bits here. Okay, so this is my journey, and I say, so are we there yet? No. I mean, the journey never ends when it comes to software development, and the journey is really the fun part, finding the next thing, maybe contributing to that thing if you think that you have ideas that can help solve problems, not just for yourself, but for others. And we never really reach the end, which is kind of good, because if we did, then there wouldn't be much left in life. But in this journey I've come so far, I'm kind of quite happy looking back at the past few years, and especially what's happened only in the last 2 years. I think that the community has come a long way in improving sizable single-page applications that run in your browser. We've got unidirectional data flows, immutability, pure and composable functions, pure UI with no data also. And of course, we've got much better tooling today than we had even just 12 months ago. Cerebral was released officially as a 1.0, meaning a stable API, about 2 weeks ago. So if you start building apps with it today, you've got something dependable that's going to hopefully remain and be supported for some time. And for me, anyway, it helps me to build fairly large, complex apps, and I'm currently using Cerebral in a project for the Railway Group. And that's it.
Any questions?
So you said what kind of view are you using? You can plug in any kind of view, but are you using React?
In my current project, I'm using React because I have a team who are used to React. In my previous project, which was much smaller, basically 1 or 2 people, I used SnapDOM. SnapDOM is much more lightweight, although performance-wise, it's arguably React is very similar now anyway. It's gotten faster with the most recent release, I believe.
Are the effects you create with Cerebral like plain objects, or are the side effects already baked in, kind of? So how is the testability of one of these chunks when you try to make a chain, for instance?
You can test actions in isolation. That's pretty straightforward. You just pass data in as you would expect and check the output. Testing chains is very easy. We actually have a helper function, a helper library, Cerebral Testable, which will basically, within your test suite, boot up a dummy controller for your module, allow you to fire signals, and then check the state before and after. So it's actually very easy to test. Cerebral, every function is pure, so you always pass in anything that would cause any side effects. So all side effects can be managed at the test level, so you can pass in stubs or whatever you need in order to do your testing.
What are the disadvantages of Redux compared to this framework?
For me, anyway, I think, to me, Redux seems as though it's not finished. And there are a bunch of other libraries coming now to kind of like help build, flesh out the picture of Redux. We've got Redux sagas and some other similar things. Cerebral, for me, is complete. I mean, it's still modular. It's still based on kind of pick and choose. You don't have to use everything. And you can even use Cerebral components within Redux if you want to. The signal implementation, there is a wrapper around that fits within Redux. So you don't have to go all or nothing. It's still a modular system. Does that answer the question?
What do you think about Angular 2 and TypeScript?
Personally or generally? I don't know. I didn't like Angular 1. I liked the idea of Angular 1. I liked the fact that you could use plain JSON. This was the one thing I kind of flirted with whilst at the same time still using Ember. But ultimately, I find the terminology is just so random. Why not just use what people understand? Call it what it is. Angular 2, I don't know that much about, but as far as I understand it, the path from 1 to 2 is just so hard, then why bother? There are plenty of other options, which I think are much simpler. Angular, to me, is much too large. It's much too complicated, and either you buy into it as a whole or you don't. I don't know if there's any middle ground.
All right, thanks. Thank you for watching this talk. Down below, you can find our channel, ViennaJS, where you can find a lot of different videos about front-end and back-end JavaScript. And feel free to subscribe.